Welcome back to my channel. In this video, we are going to see how to configure VRF-lite. VRF stands for Virtual Routing and Forwarding. It's a technology for creating separate and multiple routing tables inside a single physical router. By default, all the router interfaces and routing tables are associated with a single global VRF instance. This VRF, we can use it for the implementation of MPLS, and without MPLS, we can use this VRF as VRF-lite. And this VRF is typically used by service providers. One benefit of using VRF is we can separate the customer traffic, and another benefit is we can use the same address space. So overlapping address we can use. Now we will see how to configure VRF-lite. This is the topology I am going to use today. And router, we are using 6 routers, R1 to R6. Here, router 3 and router 5 belongs to customer A, and router 4 and router 6 belongs to customer B. In all the 4 customer routers, I only configured IP addresses, and this edge routers, I did not configure anything at all. This topology, we can see the customer A and customer B using the same address space, overlapping address space, 10.10.10.0 in the left side. On the right side, both the customers are using 192.168.1.0/24. Now we will see how to configure VRF. First, I will go to router 3. You can see the configurations. Show IP interface brief. In this show IP interface brief command, here we can see we have configured loopback interface and G0 phone interface with IP address. And the same way I have configured for R4, R5, and R6. I have configured IP addresses here. Now we have to configure VRF in the edge routers R1 and R2, but R3, this customer routers doesn't know anything about VRF. So now we are going to configure VRF in the router 1. So I'll go to router 1. Router 1, we can see the routing table. First, I will show you the global routing table. Show IP route. This is the global routing table. Only I have configured a loopback interface here. No other interfaces I have configured so far. First, we are going to configure VRF for both the customers. The command is IP VRF, and the name of the VRF I am going to give A. This is for customer A. And one more VRF we are going to create for customer B. The name I am going to give is B. So now we have created VRF A and VRF B. Now we have to assign VRF to respective interfaces. So what I am going to do here, interface G03, which is going to router 3, I'm going to assign for VRF A. So I'll go to interface G03. The command is IP VRF forwarding. Here we have to give the VRF name, VRF A. And the next one for R4, G04. G04 and interface is going to router 4. So in the G04 interface, I'm going to assign VRF B. So IP VRF forwarding B. Now I have assigned the VRF A and B to respective interfaces of router 1. Now I'll move to the same way I'll configure in router 2 also. I'll move to router 2. Now in this router 2, we will configure VRF. I'll go to configuration mode. We will configure VRF A for customer A and VRF B for customer B. Now we will assign this VRF2, respective interfaces of router 2. Interface G05 is going to customer A. So first I'll go to interface G05. This is going to router 5. So I will map this interface to VRF-A, IP VRF forwarding. A. The same way, interface G06 is going to connecting customer B. So interface G06, this is connecting router 6. So we will assign VRF-B, we will map VRF-B to this interface. Now we have successfully configured VRF-A and B in both router 1 and router 2 and assign these VRFs to the respective interfaces. I will say these configurations. Now we will configure the IP addresses in both the interfaces of router 1 and router 2. I'll go to router 1 first. Interface G03. IP address is 10.10.10.1, 255, 255, 255.0. No shut. And interface G04. The same IP address we are going to assign. No shut. Here we can see for both the interfaces, we have assigned with same IP addresses. Here both the customers are using the same address space. In general, we cannot use same IP address in multiple interfaces of single router, but this is the main advantage of using VRF. We can use the same IP address in multiple interfaces. And the same way I will go to router 2. First, we will configure the IP addresses in interface G05. This is going to customer A. The IP address is 192.168.1.2. 192.168.1.2. The same way we will assign IP addresses in interface G06. This is connecting customer B. Here also we will use the same IP address for our lab purpose. And I will show no shutdown command. Now I'll go to router 1. Now I'll show the routing table. Show IP route. Here it is not showing any IP addresses we have configured now except the loopback IP address, because this is a global routing table, because we have configured these IP addresses in the respective VRF instances. What we have to do, we have to issue this command show IP route VRF and the VRF name VRF-A. Here we can see our IP addresses, what we have configured just now. And we have another routing table for route VRF-B. So we have to issue show IP route VRF-B. Here we can see the respective network prefixes we have configured here. The same way router 2 also, we have 3 routing tables. One is global routing table, and another 2 is for VRF-A and VRF-B. Okay, now we have to configure router 1 and router 2 connecting interfaces, that is G02 and G01. I'll go to the configuration mode. Here, one thing we have to consider before configuring, we have the single link connecting R1 and R2, but here we have to use two VRF because the two VRF traffic will flow through this. So to separate the traffic, we can use the two physical link or we can use the sub interfaces. For this lab, we are going to use the sub interface. So first we have to create the sub interface. So I'll go to interface G02. I have to give the no shut command here in the physical interface. We no need to configure any IP addresses on physical interface. Now we are going to create the sub interface. Interface G0/2.1. This is the first sub interface we are going to create. And the command is we have to use the encapsulation .1q. And here we have to give the respective VLAN ID. I'm going to use VLAN 10 for VRF-A. And now I'm going to configure the IP address 15.15.15.1 and subnet mask is 30. So 255.255.252 subnet mask. Here, one thing I forgot to do, we have to assign the VRF to respective interfaces. So here we have to issue IP VRF forwarding, VRF name A. Here we can see IPv4 disable and addresses are removed due to disabling VRF-A. So we have to configure the IP address again. Okay, now we will create the another sub interface for VRF-B. So now this time I will use 2.2 and we have to use the encapsulation .1q. VLAN I will use 20 for VRF-B. And now we have to issue the IP address. For VRF-B also, so before issuing IP address, we have to give the IP VRF forwarding command. Here we have to assign VRF-B. Now only we have to assign the IP address. I'm going to issue the same IP address we are used for VRF-A. Now I'll save this configuration. Now I'll go to router 2. We'll do the same thing there. Interface G01. This is a physical interface. We have to issue no shut command. No need to give IP addresses here. Now I'm going to create sub interface 1.1 encapsulation .1q and the VLAN number I am going to give 10. This is for VRF-A. And now we have to issue the IP VRF forwarding command. The respective interface, respective VRF name is VRF-A. And after that, we have to issue the IP address command 15.15.15.2 subnet mask 255.255.255.252. And again, we have to create another sub interface 1.2. This is for VRF-B. So VLAN 10, here we are here I'm mapping the VLAN 20 and VRF forwarding. I'm mapping this interface with VRF-B and I'm giving the same IP address for this interface too. and I'll save these configurations. Now we can check the routing table in the router 2. In the global routing table, other than loopback interfaces, we cannot see any IP addresses here. And I'll show the routing table of VRF first. Here we can see it is assigned with 192.168.1.0 and 15.15.15.0 networks. The same way VRF-B also, it is assigned with 15.15.15.0 network and 192.168.1.0 network. Now we have to check the connectivity between both the sides of customer A and customer B. Provide connectivity between sites. We have to configure routing. Here in our case, we are going to configure OSPF on all the routers. First, we will configure OSPF on all the customer routers, R3, R4, R5, R6. I'll go to R3 first. Router OSPF 1, routing process 1. All the interfaces. Area 0. Here I have configured OSPF in all the interfaces. Save these configurations here, and I'll go to R4. We save these configurations, and I'll move to R5. We save these configurations. I'll go to R6. Save these configurations. Now I have configured OSPF in all the customer routers. Now we are going to configure OSPF in router 1 and router 2. I'll go to router 1 first. Here we have to configure OSPF. So command is router OSPF 1. But here what we have to do, we have to configure OSPF for separate VRF instances. So we have to check the additional configurations. VRF. The VRF name we have to give VRF-A. Under this, we have to issue the respective interfaces we have to assign with that. So 10.10.10.1. 255, 255, 255. We are configuring this G03 interface here. Area 0. And another interface is 15. 15.15.15.1, that is interface G02. And here we can see the neighborship formed between router 1 and router 3. The same way I'm going to configure OSPF in OSPF for VRF-B. Router OSPF 1, VRF-B. I think we have to give the different process number. Yeah. Under this, we have to configure networks related to VRF-B. Here also we will use the 10.10.1. This is belong to router 1 to router 4 interfaces. This 10.10.10.1 is connecting router 1 and router 4 VRF-B, and other interfaces connecting R1 to R2. This network is 15.15.1. So once we issue the 10.10.1 command, we can see the neighborship formed with router 4. Control set. Now we have saved the configurations for router 1. We have issued the OSPF configurations for both the VRF here. The same way we have to configure OSPF in router 2. I'll go to router 2 and configurations, router OSPF routing process 1. First, we have to configure this for VRF-A for customer A, and the networks we're going to configure for 192.168, 1.2, 255, 255, 255, 255. This is for G05 interface and area 0. And another interface G01, that is 15.15.15.2. Here we can see neighborship, OSPF neighborship formed between router 2 and router 5. Also, we can see here router 1 and router 2 form neighborship. So we can see this is the router ID of router 1, 15.15.15.1. That's a router 1. The same way we have to configure OSPF for VRF-B. VRF-B, we have to change the process number here, VRF OSPF2. And the same way we have to give the network number. This 192.168.1.2 is connecting G06 interfaces. This is for VRF-B. The same way for G01 interface. Now we can see that it is having neighborship with router 6 is formed. And the same way 15.15.15.2. This is also belong to VRF-B. I'll save this configuration now. Here we can see it's formed neighborship between 10.10.10.1, that is router 1. Now we have successfully configured OSPF in all the routers. Now we have to check the connectivity from router 3 to router 5, that is customer A sites. For both customer A sites, we have to check the connectivity. I'll go to R3 now. I'll ping R5 loopback with IP address. First, I'll go to the routing table, show IP route. Yeah, we have the route for R5 loopback interface. I'll ping 5.5.5.5. This is R5's loopback interfaces. This successfully pinging. Now we have formed the connectivity between R3 to R5 using VRF. At the same time, I'll go to R1 R1, we will see how to ping from R1 to R5 or R3. So now we'll check the connectivity between R1 to R3. I'll ping the IP address of R3 is 10.10.10.3. It is not working because we have to issue the VRF along with ping. Otherwise, it won't work because the interface is mapped with VRF-A. So what we have to do? Sorry, I have to change the command. Ping VRF-A, VRF name, VRF-A, and the IP address 10.10.10.3. Now it should work. Yeah. The same way when I change VRF-B, I can ping the IP address of R4. R4's IP address is 10.10.10.4. It is working fine. The same way I will connect with router 5. Router 5 IP address. I have to use VRF-A. That is customer A. So the loopback IP address is 5.5.5.5. It should work. Yeah. But the same time, if I use instead of VRF-A, VRF-B, it should not work. It will not work. So this is how we have to use the ping command in the VRF environment. That's all for now. I'll see you in the next video soon.